Good day, students. Welcome to part 2 on reviewing operations on complex numbers. We're going to be going over what we studied last time. We're going to be going over division, multiplication, addition, and subtraction of complex numbers. We're going to be reviewing this for operations within the context of two examples. So write down the heading for this lesson, review on operations on complex numbers. We're going to start out by considering example 1. Let's write down the instructions for that. It says simplify 4 minus 3i minus 7 plus 4i, graph and find the norm or absolute value of the solution. Okay, so what we're going to do first is we're going to simplify this expression, and then after that we're going to graph it. We're going to graph the solution and then find the norm or the distance from the origin. Okay, all right, first of all, let's simplify. So in this case we have 4 minus 3i minus parentheses 7 plus 4i. Anytime you're doing a subtraction problem, you always want to put the parentheses here because this minus does affect the sign of the numbers for the real number and imaginary number of what you're subtracting. Okay, so now I'm going to distribute this minus to these two terms, these two values. So I'm going to enumerate, the top stays the same, 4 minus 3i. And then I'll distribute negative to 7, it becomes negative 7. And I distribute negative to positive 4i, minus times the plus is minus, you have minus 4i. Alright, now I'm just simply going to combine like terms vertically. Alright, so for the real part, 4 minus 7 is negative 3. And for the imaginary part, minus 3 minus 4 is minus 7i. Alright, so there goes your final result. Okay, so my solution, I'm going to call it z. Alright, I'm going to call it z, standard notation for complex numbers. So z, my final answer is negative 3 minus 7i. So to do this, to graph this, I'm going to be graphing the point. Negative 3, the real part is like an x coordinate, and then the imaginary part is like a y coordinate. So that's what I'm going to be graphing. Since they're both negative, that means that my point is going to be located in quadrant 3. Alright, so let's make a coordinate system. This is just a sketch. Alright, so let's see. So negative 3, 1, 2, 3. Boy, it's negative 3 right here. And then we'll go down 1, 2, 3, 4, 5, 6, 7. Down here is negative 7. And then we have to label our coordinates too, to indicate the real one and the imaginary one, alright? So first of all, the point negative 3, negative 7 is right here. This point right here is point z. Alright? The y-axis is my imaginary axis. And then my x-axis is my real axis, okay? Alright, so there goes point z. Now I have the graph and the solution. Now I need to find the norm or the distance from the origin. Okay, so let's call it norm or absolute value. That one is basically, we're going to use the Pythagorean Theorem. So we have z squared is going to be negative 3 squared. That's a squared plus b squared, which is negative 7 squared from the Pythagorean Theorem. Alright, so we're going to have z squared equals 9 plus 49. 9 plus 49 is 58, so we have z squared equals 58. So to get the absolute value of the complex number, we'll take the square root of both sides. So we root the left and we root the right. And then that gives us the absolute value of z equals root 58. Can I simplify root 58? Well, let me check and see if I can do that. So let's take out 58. 58 is even, so I can take out the prime number 2. I'll be left with 29. 29 is prime. No factors repeat, so this cannot be simplified. So absolute value of z stays that way. So what does this basically mean? This means that the distance of a complex number -3 minus 7i from the origin is root 58. Okay, let's indicate that in the graph that we just constructed. So this graph that we just constructed, we can show what this solution means graphically. So from the origin to the point, this length right here, this distance is root 58. Okay, so this distance is the absolute value of z and is equal to root 58. Okay? Alright, so there you have it. Okay, let's go ahead and try another example. So for example 2, we're going to be doing the same process for this complex number 2 minus 3i divided by 3 plus 4i. Okay? Alright, so the goal again is just like before. We want to simplify, graph, and then find a norm. Okay, so how do we divide complex numbers? All you need is you need to find the complex conjugate of the denominator, and then you multiply the numerator and the denominator by that. Alright, so the complex conjugate is what you get when you take the opposite of the imaginary component of the whole number. So it's going to be 3, instead of 4 plus 4, it will be minus 4i. Okay? And then multiply that to the bottom, and then also to the top, you're going to multiply 3 minus 4i. So what you're going to do here, you're going to distribute, and then we're going to simplify, okay? Alright, so let's distribute. Remember, when you're multiplying complex numbers, your I can have a power that's bigger than 1, okay? I squared is -1, and then it goes on and on like that. Keep that in mind. Alright? So now let's do this. So for the top, I'm going to follow it out or distribute. 2 times 3 is 6. 2 times -4 is -8i. -3 times 3 is -9i. And then -3i times -4 is going to be positive 12i squared. Okay? And then for the denominator, we're going to multiply that out. We're going to have 3 times 3, which is 9. And then 3 times -4 is -12i. 4i times 3 is positive 12i. And then 4 times -4 is -16i squared. Alright? So let's simplify that further. We're going to have 6. Now minus 8i minus 9i, signs are the same, so we add and keep the sign. It's going to be minus 17i. And then what is I squared? I squared is -1, so we're going to have plus 12. We're going to replace I squared with -1 by definition. So we have that divided by, and then in the denominator, what do we have? We have, let's see, these two are opposite, so they cancel out. So we just have 9 minus 16 I squared again. Remember, I squared is -1, because remember, I is the square root of -1. And when you square both sides, you get that. Alright, so I squared replaced with -1. Now we're going to simplify further. And then that's going to give us 6 minus 17i minus 12. Because minus times plus is minus, divided by 9 plus 16. Because minus times minus is plus. Alright, and then we'll simplify further. We combine 6 and -12 to give us -6 minus 17i over 9 plus 16 is 25. So if I want to write this in an a plus bi form, my complex number z is going to be -6. Let me write that again. It's going to be -6 over 25 for the real part, minus 17 over 25i. Alright, so there you have it. Alright, so if I wanted to graph this, I'm going to be graphing the point negative 6 over 25 and negative 17 over 25. Alright, so let's go ahead and graph that point. It's going to be in the third quadrant. So it's just a sketch, so I don't want to find out. So let's just graph this. So we're going to have, let's just call this negative 6 over 25, and that negative 17 over 25. This is the imaginary part, and this is the real part. And then the point is going to be somewhere here. Okay? And then let's go ahead. Yeah, that's Z right there. Okay? So we have the simplified expression. We have the graph. Now let's find the norm, or the distance from the origin, or the absolute value. Okay, so the norm is called norm or absolute value. Doesn't matter what you call it. To find that, we're going to use Pythagorean Theorem. So we know z squared is going to be a squared plus b squared. So this is like an a right here, and this is like a b, and this is like a c. Okay? So using Pythagorean Theorem, we have negative 6 over 25 squared plus negative 17 over 25 squared. That's a squared plus b squared. We're going to work that out. We'll have z squared equals 36 over 625, square top and bottom, plus 289, so that's 17 squared over 625. And then we can combine them since the denominators are the same. We're going to have 325 divided by 625. To get z by itself, we take the square root of both sides. So you root this, root the top, and root the bottom. Okay? After doing that, you're going to have the absolute value of z, or the norm of z, equals the square root of 325 over, you know, when we square 25, we got 625. So when we root 625, we end up with 25. All right? So let's see. Can we break down 325? I have no idea. Let's try it out. So 325, let's extract prime factors. Since 325 ends with a 5, I'll take out a 5, and I'll be left with 65. This ends up with a 5, so I can also extract another 5 as a factor, and 5 goes into 65 13 times. Alright, so this two numbers repeat, so they can come out as just one, as a 5, and then this 13 stays behind. Okay, so absolute value of z is simply going to become 5 root 13 over 25. Okay? But wait a minute. 5 does go into 25, right? So I can divide top and bottom by 5, right? So let's go ahead and do that. 5 goes into itself once, and 5 goes into 25 5 times. All right? So this absolute value simplifies further into root 13 over 5. Okay? So what does this mean? This basically means that the distance of the complex number negative 6 over 25 minus 17 over 25i from the origin is root 13 over 5. All right, root 13 over 5. So we can illustrate that in our graph just by drawing, connecting root 13 over 5 to the origin. Let me just put that on the graph. Just connect that right here. Okay? And then that measure, this measure right here, is root 13 over 5 as the absolute value of z. All right? So there you have it. So thanks so much for watching this presentation. Please feel free to subscribe to my channel. and request videos if you need help with math. More videos can be found at math.serve.com. Thanks again and have a wonderful day.